This video is about the research on partial guided method for flute tutoring. Instrument learning is essentially popular nowadays. Many people are learning various types of instruments now. Focusing on Chinese bamboo flute, we intend to make something for flute tutoring. Traditional instrument learning method is time-consuming. It includes a lot of steps, which cause learners giving up. Learning process starts with understanding music notations, then decoding the notations to pitches and beats. Lastly, mapping the music semantics to performance motions. Focusing on flute, we intend to find a faster way for people to learn by themselves. Here's what we have already realized in the previous version. We used a servo motor, and we controlled the stick with the servo. Here's the demo of our first version. We also made user studies by comparing learning with our project and learning from video tutoring. Here's the result from learning with our project. Here's the result of learning from video tutoring. It shows that learning by haptic partial guidance is 30% more efficient than learning by video tutoring. Although the result is significant, we still want to develop more. It's clear to see the user's fingers are pushed up and down, having no degrees of freedom. Therefore, we intend to make a flute with detach and attach mode. Users have freedom to move. Only when they move incorrectly, the device will push it up or pull it down. So here's the first version of our 3D modeling. We used two servo motors to control one stick in order to realize the detach and attach mode. Here's the testing video of this version. The problems with two servos version is, first, it needs too many wires for connecting two servos. Second, 2 servos is complicated and inconvenient for controlling one stick. Third, the accuracy cannot be guaranteed. In this case, we come up with the second version, which is DC motor version. We used this kind of DC motors with encoder, and we connected with the special gears. Here's the 3D modeling of our motor version. Here's the gears we make. By letting the DC motors rotate 360 degrees one time, we will realize the detach and attach mode by only one DC motor. Here's the Arduino code for controlling DC motor. This part is the most important part. This code is for the encoder counting in order to check how many angles the motor has already rotated. By categorizing different possibilities, we can make sure if the DC motor is spinning clockwise or counterclockwise and how many counts has been already rotated. This part of code is telling the motors to spinning 360 degrees clockwise. If it exceeds 360, stop the DC motor. Here's a demo of letting the DC motor spinning 360 degrees every time. The problems with DC motor version is, first, the coding is much harder than using servos. Second, motor needs more voltage than servo did, and the structure will be more complicated. Third, controlling motor with encoder is very hard and not accurate at all. Therefore, we come up with the third version, linear servo version. Here's how the linear servo works. Here's the code for controlling linear servo. You can easily write the angles to the servo and it will move according to the code. Here's the 3D modeling we made for placing the linear servo motor. Here's the result of controlling by only Arduino code. We also want to make a control interface by processing and control it from processing. We successfully realized the linear servo version with one finger. It will be easier and reliable to realize with 6 fingers. After controlling 6 fingers successfully, we can combine it with processing, which have the MIDI information for different songs.